A coin having probability P of coming up heads is successively flipped until the off heads appears. What is the probability that the number of flips required is n? So instead of going straight to the answer, I'm going to solve two simpler versions of this question so that we slowly progress to the answer. So let's look at the first question. Find the probability that a head first appears on the 5th trial. So for this question, we are basically looking for a case where you're going to have a tail, and a tail, and a tail, and a tail, and a head. Because we know that the head appears first on the 5th trial, so there cannot be any heads before it. And there's only one way this happens. And the probability of this sequence of results is going to be 1 minus p. Since the probability of getting a head is p, it will be 1 minus p for tail to the power of 4 times p. So now let's look at the second sub-question. The probability that the second head appears on the 5th trial. So how would it look like on a possible outcome? You can get something like tail, 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 head, head. So then this would be the second head. But then the first head can appear within any of the 4 trials. So basically, you're going to have 4 possible sequences. Basically, these would be the 4 ways of getting one head in the first 4 trials and then getting one head in the 5th trial. So for these 4 ways, and each of these 4 sequences have the same probability, which is 1 minus p to the 3rd power, and then p, and then there are 4 ways of rearranging these guys. So now we are ready to tackle this initial question. So we know that we are going to have n flips as given by the question. So you're going to have some heads and tail, heads. But you know that we stop at the nth flip as soon as we have all heads. What does that mean? So for one thing, we know that the last guy has to be a head. And within the first n minus 1 flips, you are going to have r minus 1 heads. The question would become how many different sequences you can arrange and still satisfy this pattern where you get r minus 1 head in the first n minus 1 flips, and then you get a head at the very end. So if you've been looking at the previous 2 examples, it's going to be n minus 1 choose r minus 1. That's all the possible rearrangement for the first n minus 1 flip where r minus 1 heads are present. And then you're going to write down the same thing again. So how many flips of heads are you getting? I mean, actually this is for tail. So for n minus 1 heads, you're gonna get n minus 1 minus r minus 1 tails, which is n minus r. So the number of tails is n minus r. And what about the number of heads? Well, it's n minus 1 from here, but then plus the last head. So actually that will be r heads. So there you go.